So we have all this machinery out now. We discussed that light can be a photon or a wave. And for waves, we discussed frequency and wavelength. And so what I'd like to tell you now is like, well, okay, this is all fine. Those models are all fine, but where does light come from? What is the origin of light? What causes it to happen? In other words, another way of stating that question is, where do these photons and waves even come from? Okay, so a couple of videos are going to be required for this. This one I will tell you where photons come from. And in a subsequent video, I'll tell you where waves come from. And what I mean by photons always is reserved for light photons. And of course, waves can be all kinds of waves and strings and water and all that sort of thing, but we're always going to be talking about light waves as we proceed. So where photons come from is essentially, though, the one word answer is they come from atoms. Okay, so you might have some model of an atom, which is fine, where you have a nucleus. You probably remember this from high school chemistry, and an electron. And what the electron does is the electron sort of goes around the nucleus like this. This isn't the absolutely correct model, but it's fine for us. And so what can happen is, of course, I'll show you an animation of this in a minute, but this little electron here just goes around the nucleus like this. And what can happen to the atom sometimes when it sort of sits there, whether it's in the sun or in a laboratory or something like this, is if you sort of add like a disturbance to the atom. And disturbance can be a lot of things for an atom like that. It can be like some sort of big time electric shock, or even another photon from another atom. But what can happen when that happens to this atom that we have here with our nucleus is the nucleus is largely going to be unaffected by that and most things that we do in astronomy, other than, of course, how the sun works. But what will happen is the electron that was in sort of this so-called orbit here is going to jump up to a higher orbit. Okay, so compared to two atoms I've drawn here, in this one I have the electron sort of going around this orbit right here, which might be this one right here in my second drawing. But what I'm telling you is after this disturbance happens, like the electric shock or the photon, whatever you want to think about it to be, whatever you want it to be, the electron is going to jump up to a higher level now. And in that case here, the electron is said to be excited or in an excited state. So again, we're all just talking about atoms here at the moment. And let me just run over to this model here so you can sort of see this animation here. This is what we're talking about here with the atom. So you can see the nucleus there, the proton, the red part in the middle. That would be the positive sign that I drew. And this little electron right here is just whizzing around it. And all these so-called orbits here are in these dotted lines because the electron can be in these higher orbits depending if you get a good disturbance going on in there or not. Okay, so that's just sort of the model that we're talking about. And so what will happen, though, is after this disturbance happens, and I'll show you a disturbance on that animation in a minute here, but after this disturbance happens and the electron is in this higher level, what will happen, though, is it's kind of looks at this and goes, it doesn't really like being in this level here. It's sort of not relaxed. Okay, this is the atom in its most relaxed state here, and for that reason, sometimes this state here is called the ground state. That's where the atom likes to be. It's the most natural state for the atom. It's the way the atom was made. The electron wants to be down there. But after the disturbance, it found itself in this higher level. So can you think of what happens to this atom here after, let's just say a little time goes by. You have this atom in this excited state. What happens after a little time goes by? Well, you'd be right. The electron wants to relax again, so the electron is actually going to fall from this upper state back down to the lower state. The electron will fall. Okay? And this falling is exactly, I don't remember where my letter was now, so right there. This falling is exactly where photons come from. So when this electron makes this transition from here down to here, when it falls, this falling motion right here, as it falls, I gotta only do this so many times, I'm gonna let it go now, but as it falls here, then what happens when it falls, and let's just pick some color we haven't used, maybe like this purple here, when it falls, then out comes a photon. Photon is born. So that's where photons come from. Photons, they come from falling excited electrons. That's where photons come from, and that's always the case. There always has to be an electron that's falling, and when that happens, a photon comes out of a specific color. We'll talk about color too. So if I go back to the model here, the model's a bit limited, but I'll try to point this out to you. You have to watch it very carefully. And the disturbances that we can sort of impinge on the atom in this particular model are other photons. Remember I said disturbances can be a variety of things, electric shock or photons. So let's just send some photons in. I'll turn on this funky looking gun here. So there goes the photons in. And so what I need you to do is see, as soon as these photons went in, they disturb the atom. And I'll stop talking a minute. I just want you to watch that sometimes that electron will absorb one of these photons. These are all a bunch of photons coming in here from the bottom. These are all photons going up. It'll absorb the photon and instantly get jacked up to one of those excited states. It'll hang there for a while, and watch very carefully what happens when it falls. A photon will come out. There. See that red photon going across? There's another red one. There it's very high and then falls again. There it's excited, falls, there's a photon coming out. Just watch it for a bit. Every time the electron goes to a smaller circle, a photon comes out. There's a purple photon. There's a red one coming out. There's another red one coming out. There's another red one. Ooh, nice red one coming out there. So I don't know where these photons came from that are causing this to happen, but you can clearly see that when that electron falls, this photon itself comes out of the atom and the electron goes back to its so-called ground state. Okay, so that's the moral of this story. That's where light photons come from. Anywhere in astronomy, in the sun, or wherever, whenever an excited electron falls, then a photon comes out. So we can just wrap up the picture one more time. I realize this video is going a tad bit longer than I wanted to, but it'd be something like this. Here's the atom. You disturb it. And what will happen then is the atom will be, here's that other state here. Here's the excited one with the electron in it. And what will happen is the electron is going to want to fall. And when it falls, out comes a photon. So that's the story of where photons come from.